All right, if we think back to last lecture and last chapter when we're talking about the start of kind of our climate, one of the big things that we looked at was rising air. And so if we get air to rise, it's going to cool and then it condenses. We get our cloud and then we get precipitation. In some cases, we continue to get that air to rise, and it's going to rise enough so that we don't just get precipitation in some form, but we're going to get more severe weather because we have a taller cloud. Now, there's three ways for us to get storm formation and really cloud formation in general. So we're either looking at convection, orographic lifting, or frontal systems. Convection is going to be rising air. So we heat the ground up just like when we boil a pot of water. The air heats up and starts to rise, and as it does, it cools, condenses, and makes us clouds. Orographic lifting is when we're going to move our air mass over a topographic barrier. So when it runs into, say, the Rocky Mountains, it can't necessarily go through them and find those little gaps, so it gets forced upwards, and when that happens, it's going to be forced to cool, and we're going to get clouds to form. Our last option is kind of through frontal systems. And if you think back to what happens when we have cold air moving into warm air or warm air moving into cold air, in both cases, that cold air is going to stay closer to the ground, and so that warm air is forced to rise, and in that way we can get clouds as well. Convection is going to be our least destructive. We typically call this an air mass thunderstorm. We have these a lot in tropical locations. We'll see them here in the mid-latitudes, especially in the United States, in the late summer afternoon, where we've had time all day for that warm surface to heat up. As does that, the air over it starts to heat up, it rises and it cools, and then we get clouds to form, and then the potential for precipitation as well. Orographic lifting, here we can see what I was talking about briefly before, where we have an image. So the air is forced to rise over that topographic barrier, and as it does so, it's going to cool and condense. It a lot of times gives us what we call the rain shadow effect, where we have rainy conditions fairly prominent, in our case in the United States on the western side, and then warmer and drier side there on the right. And so if you think of Seattle versus Tacoma in the Cascades. And then here's an example of our frontal systems again. And here on the top image, we have warm air moving over cold air. Remember that cold air wants to stay near the surface, so that warm air is going to kind of slide up the back of it, and we're going to get precipitation in front of where the temperature change takes place. If we go to the bottom image, we see cold air basically barging its way into where that warm air is. What it does is it quickly pushes that warm air up, that warm air cools, condenses, and creates clouds. Now, in all of these cases, depending on how strong that uplift is of the air, we can get storms that are going to come out and be potentially dangerous rather than just precipitation that might be light or kind of mild without things we see in storms, lightning, hail, and heavier precipitation. Once we get our storm to form, regardless of how strong it is, we have three stages. So the first stage is where we have all upward movement, and so we have that rising air that's cooling and condensing. During the mature stage, which is our image there in the middle, we have rising air, but we're also starting to get our precipitation, so we get a downdraft. And so as long as they exist pretty parallel to one another, up and down, our storm can continue to grow into mature. Once that downdraft takes over, or we don't get updraft for whatever reason, we have the dissipating stage where really everything then is moving downward, and we're kind of killing off our storm there. We're going to finish up our precipitation to the end.